In this video, I'll be discussing the 2019 AMC 10B question number 20. As shown in the figure, line segment AD is trisected by points B and C, so that AB equals to BC equals to CD equals to 2. 3 semicircles of radius 1, arc AEB, BFC, and CGD have their diameters on AD, and are tangent to line EG at E, F, and G respectively. A circle of radius 2 has a center on F. The area of the region inside the circle but outside the 3 semicircles shaded in the figure can be expressed in the form A over B times pi minus square root of C plus D, where A, B, C, and D are positive integers and A and B are relatively prime. What is A plus B plus C plus D? For this problem, we have to split the shaded region into parts that we can find the area of. First, call the upper semicircle X. These two parts, Y, and bottom part Z. Now, we know that AB equals to 2, BC equals to 2, and then CD equals to 1. We also know that the radiuses of the 3 semicircles are 1. So these two are the diameters. So, if we draw this line here, these will all be 1. 1, 1, and 1. And this will be 1, 1, and 1 also. And then EF equals to FG equals to 2. 2 is the radius of the large circle F. Okay, now let's start with the problem. Connect EG. X equals to 1/2 times 2 squared pi, which equals to 2 pi. Well, EG is going to be the diameter. And then X is going to be the upper semicircle, meaning that it's going to be 1/2 the area of circle F, so it equals to 2 pi. Okay, let's solve Y now. To solve Y, we can first connect EB and BF. And then we can call this part H and this part J. So, this is going to be part 1, part 2. Part 2 is going to be connect EB, BF. And then draw the radiuses. So, construct EH perpendicular to AB. Okay, so we can mark this little part as the striped region. So Y equals to A triangle EBF minus 2 times A striped. Triangle EBF equals to have an area of 2, which is EF, times the radius 1, because the height will be equal to the radius of the semicircles, times 1 times 1/2. Minus 2 times parentheses A striped. Well, the A striped is going to be a bit more complicated, but solvable. It'll be this quarter semicircle. So 1/4 times 1 squared pi. Minus area of triangle EHB, which is going to be 1 times 1 times 1/2. This equals to 1 minus 2 times pi over 4 minus 1/2. This equals to 1 minus pi over 2 plus 1 equals to 2 minus pi over 2. However, we want to find 2y because there's 2 of these. So 2y will equal to 4 minus pi. Last but not least, we had to find part 3, z. Z. How do we do that? Well, let's connect these two parts. So for your benefit, I can draw a smaller part here as the sector. So we have these two. F, M, N, O. So we can mark this M, N, O. Okay. So construct FO perpendicular to MN. Connect MF and NF. Since OF equals to 1, MF equals 2, NF equals to 2, so triangle MOF and triangle NOF are 30, 60, 90 right triangle. So MO equals to NO equals to square root 3. And angle MFN equals to 2 times 60 degrees, 220 degrees. So Z will equal to 1/3 times 2 squared pi minus these two 30, 60, 90 right triangles. So it's going to be 1 times square root 3 times 1/2 times 2. Okay. Times 4 over 3 pi minus square root 3. If you're wondering why it's 1/3, well, since we know that the central angle is 120 degrees, well, 120 out of 360 will be 1/3 of the total circle's area. Now that we have x, y, and z, we can find the total area now. So A total equals to x plus 2y plus z equals to 2 pi. I'm going to move the paper a bit. Okay, equals to 2 pi plus 4 minus pi plus 4/3 pi minus 3. This will equal to 7 over 3 pi plus 1 minus square root 3. So then here we can get that A plus B plus C plus D will equal to 7 plus 3 plus 1. 7 plus 3 plus 1. Wait, I made a typo here. It's going to be 4. Plus 4 plus 3 equals to 17. So our answer is going to be E. Key concepts here is going to be that you have to find out that how to split the shaded region into parts that you can solve for. So this is going to be x, y, and z. X is going to be pretty simple. Y, learn to make the helping lines. As for z, well, you have to understand concepts of 30, 60, 90 right triangle because it helped us to find central angle MFN. Then we just solve for the area. of z. And then we just added x, 2y, and z to find out the total shaded area. And then we can complete the problem. Thank you for watching.